distance time graphs. Now, what if I ask a question like this? If a vehicle travels within a speed of 60 kilometers per hour, how much of a distance will it travel in 1 minute? What do you think? If a vehicle travels 60 with the speed of 60 kilometers per hour, how much of a distance do you think it will travel in 1 minute?
1 kilometer?
Huh?
1 kilometer?
1 kilometer. That is correct. How did you come up with that answer?
Because there's 60 minutes in 1 hour and 60 kilometers, so 60 divided by
Exactly. So basically, in 1 hour, this travels 60 kilometers. 1 hour is 60 minutes, and hence 60 kilometers, which means that in 1 minute, this travels 1 kilometer. Correct?
yeah.
Now, this is a basic simple idea we have. Now, you see that when speaking of distance time graphs, this is some kind of a speed that we are talking about. But the speed, as you can see, we have broken down into two terms, distance and time. Therefore, there should be a certain relationship between speed, distance, and time. From your point of view, from your knowledge, what do you think is the relationship between speed, time, and distance?
Um, so I'm kind of like confused.
Exact. Right, fine. We say that speed is equal to distance divided by time. Are we clear?
Yeah,
We know for a fact that mathematically 1 over x is x to the power minus 1, correct?
yeah,
Now this kilometers per hour, this can be written as such. Also, we say it as kmph, kilometers per hour, or else it is written as kmh minus 1. Yes or no?
yeah,
All these units are the same, they give the same meaning. Here, distance is in kilometers, correct?
yeah,
And the time in hours. So if I write this, speed is kilometers divided by hours, it is like speed is kilometers into 1 over hours. Yes or no?
yeah,
So this 1 over hour, I can write this same thing as kilometer into h to the power minus 1.
yeah,
Then I can write speed is equal to km h minus 1. Are we clear? Yes or no?
yes,
Right. So now you should understand before learning anything that speed is equal to certain combination or relationship with distance and time. Therefore, speed is equal to distance over time. And if the distance is in kilometers and the time is in hours, it is basically km h to the power minus 1. And this is the theory of how kilometers per hour is taken into calculation. Are we clear now?
yeah.
Take this down, please.
Okay.
Now, if I draw this particular graph, let's see what you would understand. Now you want to do what distance time graphs, right?
Yeah,
Straight line graphs. Straight line graphs. In straight line graphs, what we understand is that let's assume that y is equal to mx plus c is our general equation. The c is point where the graph cuts the y-axis, correct?
yeah,
If we assume that the graph goes through the y-axis, at 0. The graph would definitely look something like this, isn't it?
Yeah.
Mathematically, if we are to find the gradient, m, the gradient, correct? This
Yeah.
is what y is equal to mx. Y divided by x will give you m. Yes or no?
Yes.
Now, if you take the same thing into consideration, if you substitute this into a distance time graph, please understand this very carefully. This is my distance, correct?
Yeah.
Let's say that this is meters. This is my time. Let's say
Yeah.
seconds. What I can find the gradient of this as well, correct?
Yeah.
What do you think is my gradient telling? This is my y, correct?
Yeah.
This is my x. Basically, simple, just like what you have here. This is our y, this is our x. And the slope is our m or the gradient.
Yeah.
Now what we have here? Y divided by x. What is this now? I am saying that the slope is my speed. Let's try to understand how it is my speed. If I say that this is my gradient, gradient is y divided by x. In this particular instance, what is my y? Distance. Yes or no?
Yeah.
What is my x? Time. Therefore, previously I taught you that distance divided by time is what? Speed. Am I clear?
Yeah.
So, m, the slope or the gradient is basically y divided by x, which means that in a distance time graph, speed is equal to distance divided by time, where speed is definitely the gradient and the y-axis is the distance and the x-axis is the time. Are we clear?
Yeah.
Yeah. So using the same theory, the same theories that we have for straight line graphs, we can apply the same for distance time graphs as well. All right?
Yeah.
Take it out, please. Now, if you further look at this clearly, I'm going to draw a very simple distance time graph. Now, let's see. Now, this is a very basic distance, let's say in meters, time in seconds. Let's say that a boy is going from home. Let's say this is our home to a shop close by. Let's say for our ease of calculation, the shop is 200 meters away. Shop is 200 meters away.
Yeah.
This child runs to the shop and he runs there to the shop in 20 seconds. He stays in the shop for 1 minute, comes back home running in, let's say, 10 seconds. Sorry, no, yeah, 10 seconds. How do we know these kind of times now? It is pretty clear for us that the time that he has spent in the shop is what? 60 seconds. Yes or no?
Yeah.
Here coming home back again, 10 seconds. And here obviously it is 20 seconds. So if I break this motion into three parts, O to A, what is happening? O to A, the boy moves know the distance? 200 meters. Do we know the time? 20 seconds. What is the speed now? We know that speed is equal to what? Distance divided by time. There, what is the distance? 200. Time 20. Now this says that the child has been moving with a speed of 10 meters per second. A bit unrealistic. A child can't run, how can I say, 30 feet in 1 second. Be that as it may, but for the calculation purpose, we'll take it as such. All right?
Yeah.
1 meter is almost 3 feet now. Right. So now the speed here is what? 10 meters per second. The boy moves from home to the shop with a speed of 10 meters per second. You should understand that I have used two different ways, but they still have the same meaning.
Yeah.
What is happening from A to B? A to B, my love, what do you think happens?
He's in the shop.
Huh?
He's in the shop.
He is in the shop. You see that there is no change in the distance. The
Yeah.
distance remains the same because child is not moving. The distance remains the same. The child is not moving. Therefore,
Yeah.
we say the child is at rest. Yes, that is, time goes on, but the distance remains the same. If the distance remains the same, you see that 0 to A, there is from 0 meters to 200 meters, there is a certain distance that has been traveled. Correct or not?
Yeah.
If I take this as my y, what height has it reached? 200 minus 0, 200. Yes or no?
Yeah.
Because there is a slope. Do you see a slope here? Do you see a slope here? Either. No, we do not. Therefore, what do you think is the speed? Speed is no distance moved, time goes 0 meters per second. Am I clear?
Yeah.
What is happening from B to C? What do you think happens from B to C?
He's going home.
He's going back home. Correct? Yeah. The child goes back home. What do you think the speed is? The distance that the child moves back home is what? Again, this 200 meters is the distance that the child is moving back. Therefore, it's 200. The distance divided by time, which is what now? 10. With a speed of 20 meters per second. Yes or no?
Yeah.
Yeah. This is what? 20 meters per second. Even though it does not look the same in the display, I tried to draw this like a steeper slope, but you understand that if
Yeah.
speed is greater, the slope is steeper, right?
Yeah.
So BDC goes back home with a speed of 20 meters per second. Am I clear by now?
Yeah.
Yeah. So the child, for the total distance the child has traveled is 200, back again 200, 400 meters. Am I clear?
Yeah.
So 20 seconds to go to the shop with the speed of 10 meters per second, 10 meters per second, stays in the shop for 1 minute, that is 60 seconds. The time moves on, but there is no change in distance, and hence the speed is 0. The child comes home back from the shop, travels 200 meters within a time period of 10 seconds, and the speed is 20 meters per second. Are we clear with this, yes or no?
Yeah.
Please take it down, my love.
Okay.
Now let's try to understand another simple graph. We say that we can say that the time taken and the distance. Let's say that here the speed that it has, the distance it has reached is 200 meters. We do not know the time. Let the time be t1.
Yeah.
Here, let's say from O, A, B. Here the time it takes is 30 seconds. Here the speed is given to us as 40 meters per second. On the other hand, this is a way more steeper slope, as you can see. The speed is 80 meters per second. What distance has it gone? Let's try to figure this out. Distance in meters, time in seconds. What do you think is the time? We know that from O to A, distance is given 200, time unknown t1, but the speed is 40 meters per second. There, speed is equal to distance over time. This is our golden equation.
Yeah.
40 is equal to 200 over t1. Correct or wrong? Correct.
Yeah.
40 t1 is 200. You take this to the other side, it gets multiplied. T1 is 10, 200 divided by 40. And hence, what is it? It has taken only 5 seconds. Yes or no? It has
Yeah.
taken how many seconds now? 5 seconds. Therefore, here it is 5 seconds. Now, this has moved a certain distance up again, which we have to find. We do not know. The time is given. So, we write A to B. Speed is distance over time. Speed 80. Distance unknown. And the time is 30. Correct? So we cross multiply them. What the distance that it has traveled? The distance it has traveled is 2400 meters. But this distance is 2400. What is the distance that I will write here? 2400 plus 200. Because from 0 we are calculating, yes or no? This is a distance of 2600 meters. Am I clear?
Yeah.
Because from here to here, the distance is 2400, but from here, it has moved total distance of 2600 meters. Am I clear?
Yeah.
So the most important part here is we have used only one simple equation on both instances, that is speed is equal to distance divided by time. Based on the graph that is provided, based on the data that is given, we have somehow used them to find the time, and in this case, find the distance that it has traveled, which is 2400 meters. Did I make myself clear, love? So this time and the distance both were derived from the simple equation speed is equal to distance over time. Are we clear?
Yes, sir. My mic was muted.
Right, take this down.
Okay, sir.